and continuing that same discussion on polynomials, what about multiplying some polynomials that have more than just one term? Okay, so we can do this by taking this monomial here and distributing that to all three terms in that trinomial. Okay, so we have 4 times 2 is 8, x times x squared. Remember, there's an implied 1 here, so that's an x cubed. 3 times 4 is 12, x times x is x squared. 4 times 5 is 20. And I have no like terms since those all have different exponents. Okay, I'm going to distribute to both terms. Let's see, so I've got 2 times 7, 14. R squared times r to the 1 is r cubed, and then I have an s. For the second term, 3 times 2 is 6. And I have an r squared, s to the 1 times s squared is s cubed. These ones are fun, and these ones come up a lot if you continue on in algebra. So multiplying two binomials, we use a process called FOIL. So that means we multiply the first, then the outer, the inner, and finally the last. Okay, so first, n times n. Okay, n times n is n squared. Then the outer. Okay, so that's 4n. The inner, minus 7n. And then finally, the last. So minus 28. N squared minus 3n minus 28. I'm going to use the same FOIL process down here. Okay, first, 5 times 2 is 10. N times n is n squared. Outer, minus 15. And then we have ny. Inner, minus 4ny. And then last, plus 6y squared. And then I look for any like terms. So these two are like terms. 10n squared minus 19ny's plus a 6y squared. Another FOIL. Okay, 2 times 4, 8. Negative y times negative y. That's plus y squared. Well, let me start this one over. So I could do it that way, but I'd rather really want to make sure I stick with this rule. So we do them all the same way. Okay, so let me see. If we do it that way, we do 2 times 4. Was that 8? Then we do the outer. So then we have minus 2y, then the inner, minus 4y, and the last, plus y squared. Combine my like terms. And there we have it. This is a special form. So you'll notice here, like, you have an a plus b times an a minus b. So let's see what happens when we FOIL this. So we get x squared minus 2x plus 2x minus 4. So you see what happens here that's interesting is those middle terms, those linear terms, actually cancel out. And so that just leaves me with a squared minus b squared. So this is a formula that we'll come across again and again, and it's called a difference of squares. So you see how here I have a subtraction of 2 perfect squares, so I recognize the 2 factors there. So that's a nice rule to keep in mind. So like I could even add another like little simple one here, so you can see how this property works. So like if I had x plus 3, x minus 3, I recognize right away that that's this difference of squares. That would be x squared minus 9. If I had x plus 5, x minus 5, that's a difference of squares. It'd be x squared minus 25. So that's like a little side note extra example. So here's another difference of squares, but it's a fancier one. So let's see what happens when we FOIL this one out. 6 times 6 is 36. R times R is R squared. Okay, and then we get plus 6R, and again, minus 6R. And then minus 1. So our middle terms cancel again. It's because we have this difference of squares. Okay, let's look at another kind of special one. So I cannot, when I have this sum here, if I have an addition or subtraction, I cannot distribute that exponent. I can only do that if I have a multiplication inside. Okay, because actually what that squared is saying is it's saying, what does squared mean? It means take the quantity and multiply it by itself, right? So I actually still have to do this FOIL process. So what is that? It's an x squared plus a 2x plus a 2x plus a 4. It's an x squared plus a 4x plus a 4. This is similar. squaring the quantity means I have to multiply it by itself. Okay, 3x times 3x, 9x squared, minus 6xy, minus another 6xy, negative 2 times negative 2, positive 4, y times y squared. Combine my like terms, and I have it. Here's a fancy one. So multiplying a trinomial by a trinomial, that's the last one. I follow that same kind of FOIL process. It's just I have to be careful with everything. So I'm going to take this first term and I'm going to distribute to all three terms there. Okay, so negative 2m to the 5th minus 4m cubed minus 2m squared. Now I have to take the middle term and distribute to all three terms. Okay, so plus m to the 4th plus 2m squared plus m. And then, as you probably guessed, now I have to distribute the 4 to all three terms. Let's see, so I get minus 4m cubed minus 8m minus 4. Okay, and then I look for like terms. So let's see, I've only got one m to the 5th term. Let's see, what about m to the 4th? Just one of those. M cubes, negative 4 of them, negative 4 of them. So negative 8 m cubes. Let's see, negative 2m squareds, positive 2m squareds cancels. What about the m's? Positive 1m minus 8m minus 7m, and then my constant. And then I just look back through it and just make sure I got everything right. Looks like it.